Welcome back. For this video, we're going to discuss factoring quadratic trinomials. We've got two scenarios: determining the factors of trinomials with a leading coefficient of 1, determining factors of trinomials with a leading coefficient that is not equal to 1. This first one here is much simpler than the second one. We have to do both. Then, of course, what is a prime polynomial? First thing we can do is show you what a multiplication of binomials is again to show you what we're about to try to do. So we're going to do this x times x here, and that will give us an x squared. X times the minus 5 will give us a negative 5x. 4 times the x will give us a positive 4x. And then the 4 times the negative 5 will give us a negative 20. And then these middle two terms are like terms. So we're going to combine them together to get a negative x minus 20. So multiplying this binomial produces this quadratic trinomial. So what factoring is all about when we do these trinomials is to get this to go backwards into that form right there. And that's what this whole video is about. So as I said, our first example is going to be with a leading coefficient of 1. And this is going to be the easier of the two types. Over here we have a general form of the equation. Normally we have an a out here, but we're assuming that a is actually a 1, which means we don't need it. So when we do this, we have to take in consideration what the b value is and what the c value is. Okay, for this example, we want to make this trinomial become the product of two binomials. And one of the easiest ways to do this is to look at that first one and ask yourself, what two factors make x squared? And that would be x and an x. The second factors that go here and here. Well, this is when we consider the c is positive, which it is in this case. So c is the positive value right here. Positive 18. When we have that scenario, we're looking for the factors c that have a sum of b. So when this is positive, it tells you two things. It tells you, one, you're finding a sum. It also tells you that two factors have the same sign. They're either both positive or they're both negative. We're talking about the factors that go here and here. Well, if you look at the middle term of b is a negative 9. Since the two factors of 18 that we're looking for have to come out to a negative 9, then our factors are both negative. So what we're going to do is make a list of factors of 18. So we're going to call them negative 1, negative 18, negative 2, negative 9, negative 3, negative 6. And we're looking for the factors that have a sum of negative 9. We can clearly see that it's negative 3 and negative 6. So our two factors are x minus 3 and x minus 6. And this is the factored form of this quadratic trinomial. In this example, we see that c is negative. So we have a negative 14. We're going to be looking for the factors of c that have a difference of b instead of a sum of b. Now this difference, this negative sign on the c value means two things. It means the difference, but it also means the two factors are opposite in signs. And if you look at the middle term here is positive, that means the bigger the two factors has to be positive. So I'm going to go ahead and write my two parentheses. And the only way I can make an x squared is an x times an x. Then I'm going to list the factors of negative 14 that have a difference of b, but the bigger of the two factors has to be positive. What I like to do is just list the factors, 1, 14, 2, and 7, and then ask myself which ones have a difference of 5, and it's clearly the 2 and the 7. Well, how do I get them to come out to be a positive 5? Well, it would be a 7 and a negative 2. So negative 2 and negative 7 makes the 14, but they have a difference of positive 5. So it would be minus 2. And a positive 7 here. This then becomes your factored form of this trinomial. All right, we have one more with a leading coefficient of 1. Again, c is negative, which means my factors are opposite in signs, and I'm looking for a difference of b. So I'm going to start with two sets of parentheses. X times x gives me the x squared. And then the factors of negative 4 are 1, 4, 2, and 2. And now one of them has to be negative, but I'm looking for a difference of negative 3. So the ones that have a difference of 3 would be the 1 and 4. And to make it a negative 3, the bigger of the two factors has to be negative. So I have to have a negative 4 and a positive 1. So I'm going to put plus 1 and minus 4 right there. And this becomes our factored form. And if you're ever unsure if this is correct, multiply this back out and you should get the original quadratic trinomial. Now this one says factor if possible. So if we try to factor this out, we know that we'll have an x and an x, which makes the x squared. And then we list the factors of 8, which are 1, 8, 2, and 4. And they have to have a sum of negative 4. Well, neither of these two sets of factors will have a sum of negative 4, which means this quadratic here is actually a prime polynomial. Okay, now we want to factor trinomials with a leading coefficient that is not equal to 1. The general form of a quadratic would look like this: ax squared plus bx plus c. You'll notice we have an a now. Instead of a 1 out in front, we have a number other than 1. And you might want to go ahead and write this down as the general form of all of our quadratics. One of the most important parts of this is to always remember to prefactor any GCF out first. You'll notice we have the a, the b, and the c values here. Well, normally we'd be looking at those three numbers. However, those three numbers already have a 2 in common. So what I'm going to do is divide a 2 out to the side, and that will reduce this, this, and this by a factor of 2, leaving me with 2x squared plus 9x minus 5. So the a value we're going to be using is the 2 here, the 9 here, and the negative 5 here. And those are the three terms that go for a, b, and c. And let's not forget we have this 2 over here. We have to attach that at the end. And what we're going to do is we're going to take the a value and times it by the c value. So 2 times negative 5 will give us a negative 10. Now, just like before, we're looking for the factors of negative 10 that have, and according to this sign right here, they have a difference of positive 9. So we're going to list the factors of 1, 10, 2, and 5. And we can clearly see the ones that have a difference of 9 are 10, but we want a positive 9, so it has to be a positive 10 and a negative 1. So we're going to rewrite this into 4 terms. I'm going to rewrite my a term first, my a squared term, so 2x squared, and my c term second, which is going to be minus 5. But this b term here can be rewritten as a negative 1x plus 10x. So what we're going to do is employ the factor by grouping by taking this trinomial and turn it into 4 terms. So now we're going to do factor by grouping. So I'm going to group the first 2, group the second 2, and the GCF for the first group here, it appears to be just an x, and the GCF of the second group here appears to be a 5. So when I factor an x out of the first group, we still have 2x minus 1. When I factor a positive 5, so plus 5, out of the second group, we still have a 2x minus 1. And just like before, we have this common binomial of 2x minus 1. So I'm going to factor that one more time. So 2x minus 1. When I factor these out, I still have a x plus 5 left over. And I'm almost done. Don't forget we had that 2 that was way out over here on the side. So I could bring that 2 down. And this right here ends up being my fully factored form. And if you ever want to be sure, multiply all that back together and you should get the original 4x squared plus 18x minus 10 again. Okay, we're going to try this one more time with the leading coefficient not equal to 1. We want to try to prefactor any GCF if we can. Well, 2, 17, and 21 do not have any factors in common. So my a values are simply 2, negative 17, 21. So I'm going to do a times c. So the first step is to multiply a and c. That would give me a 42. And now I'm looking for the factors of 42 that have a sum of negative 17. Now remember, sum means we're adding them up and they have the same sign. So the two signs are negative because I have a negative 17 here. So I'm looking for the factors of 42 that add up to negative 17. So the two factors that come to mind are 3 and 14, which makes 42. Now they have to add up to a negative 17. So in order to do that, they both have to be negative. Now essentially they both have an x on there. So I'm going to rewrite my 2x squared and bring down my 21. But this 17x in the middle is going to be broken into minus 3x and minus 14x. Because what we're using here is the factor by grouping method. So I'm going to group the first 2. I'm going to group the second 2. And it looks like I forgot to bring my positive, my plus sign down for my 21. Now the GCF of this first group here appears to be just an x. Well, something you'll notice here is that this is a negative in the first position, and up here I have a positive in the first position on the other one. So I want this to be positive just like the other one, so I need to make a GCF come out of negative 7 instead of just 7. So I'm going to go back and bring my x down. When I divide both these by x, I end up with 2x minus 3. And when I bring my negative 7 out, that's my GCF, this 14x becomes, negative 14x becomes a positive 2x, and the positive 21 will become a minus 3. And now we can clearly see we have a 2x minus 3 and a 2x minus 3. When you see the same two factors there, you know you've been doing this right. So factor that out again into 2x minus 3. And when you divide those out, those two go away, leaving you with x minus 7 left over. And if you're ever unsure again, you can just multiply these together, and you should get the original quadratic back again.